but we are going to get started. So thank you guys all for coming. Thanks for coming out to the first session, the first theater sessions of the summit. I'm Matt Turner, Director of Product Marketing at Prophecy. We're here to make sure everybody can get the data they need. I'm joined by Itai Weiss, and we have a packed full 20-minute session for you guys because we're going to tame FHIR, which, not the FHIR, but the FHIR Healthcare Data Standard, and we're going to talk about data standards and how important they are for teams to be able to wrangle, but also getting value out of your data. So we're going to jump right in because we have a lot to cover, including a great live demo. And we're just going to take a look at, there we go. Take a look at where we're starting from. So if you've been here at the show, if you've been in the data business, you know that clean, trusted data is the fuel for everything we want to do, including AI and analytics. It's not just the fuel, it's critical now. So Gartner just recently did a survey, talked about data companies that had access to data were 3 times more successful. We've actually done some surveys ourselves at Prophecy. We asked executives what was keeping them back from adopting Gen AI, and they said faster access to data and data governance. Right there, both of them there. And industry standard data, like the FHIR standard, comes into this picture in a very interesting way to help accelerate this. So normally this is the picture where we're looking at all the operational data we need to cover, many, many different sources, and it's kind of up to us to make sense of it, process it, and get it out to important destinations that we have. Industry standards help accelerate that. Oops, there we go. And it's no wonder that there have been so many successful industry standards. So in finance, you have XBRL, you have FPML, you have the shipping standards from the DSCA, arts and retail, and there's my favorite standard, which is the NISO STS. So I'm just gonna take a body poll. Does anybody know what NISO STS is? And if you answered that question, it would have been amazing. STS is the standard for standards, which, when you think about it, is a real thing. And what's interesting is that only recently came out. So the ISO and the standards bodies have been out this for many, many years doing digital, and they only recently had STS. And standards are great, but they have a lot of problems. The first thing is that they're complex. You get everybody in a room, and you start to define everything you need for a domain, and it really, really can get very complex. Second thing is they need to be extended. They need to take in exceptions. They need to take in unusual cases. And that can lead to a lot of complications down, even making it even more complicated. And the last thing is that they do change. Not only the standards change, but the payload and what you're working on. All that operational data doesn't just get encapsulated in the standard. All the changes have to get encapsulated. So this puts and that's the same thing with FHIR. So FHIR is a great standard. It's out there. It's actually really widely encompassing. Itai is going to get into it. But before he does, I just want to talk a little bit about what this means for some of the critical roles. When you're working with these standards for data engineers, it can seem like the right spot for them because it's really complex. They need to figure it out. But they don't know the destination. They don't know the purposes. And so they get into this traditional loop between data engineers and analysts where we're defining what we need. And in this case, taking out of the standard a specific use and working on that. And that back and forth delays things. It's very costly. But much, much more importantly, it puts the data engineer on the hook for everything as it changes going forward, even minor changes, because only they can understand the complexity of the standard. So everybody's blocked, analysts don't have the data, and the data engineers can't get to the larger picture jobs that they're trying to execute. Well, what if we just let the analysts take care of it? Well, there are tools to let them do that. Analysts can get hand on, but if they're tackling this giant standard for one purpose, they're just going to cut right through it, try to understand it, and that alone is going to be difficult, but it's not going to be sustainable. It's going to take them a long time, and they're going to start incurring these costs we see when analysts are hands-on doing the whole job. They're going to have to rework things as you make it codified. Data quality is going to be suspect, and because you're probably moving data around, not just having one place to work on it, you're going to start incurring security risks. So that's what we at Prophecy are up to. We've created the Prophecy Data Integration Platform to bring everybody together on one platform. We've got a lot of success with some big companies, but today we're going to talk to you about when you apply this to FHIR, what you can achieve. And Itai, take it away. I'm sorry, I had a big finish for him. So Itai will now, live on stage, tame FHIR.
Thanks, Matt. Made me laugh.
I can actually go down. No, yeah, thank you.
Can I have? So, those of you that are coming from the HLS are familiar with FHIR. FHIR was created back in 2011 and created a standard that more than 90% of the US hospitals and payer are using. to share data among their other colleagues. FHIR was intentionally being flexible, which means that it can be extended by the different providers and by the different needs that that is the purpose. And the extendability and the standard are great, but at the same time, there is a but to it. The extensions in FHIR can make the ingestion of FHIR data very, very complicated. But at the same time, this information is critical within your lakehouse. It helps you understand patient information, their allergies, the care, the doctors, the visits, the terms, everything around the payments and others that are in part of it. But the thing is that it's really hard to ingest it. And in this example, you can see, for example, that we have different structures in different files for FHIR. A lot of them are coming in arrays and JSONs of JSONs and so on. In one of them, we have two given names. In the other, we have two official names, an official and maiden. Each and every one of them has only one given name. And this has been a challenge in Databricks. But the Databricks SAs team tried to build a solution around it that used DLT and DBT, and they run it by several customers. And it was successful. It was successful for a data engineer and data scientist to be able to maintain hundreds of notebooks and bring up the complexity and work it out. But as we mentioned, FHIR is flexible. FHIR keeps changing. We'll keep getting different information for different patients and different care units and add more devices or others that keep changing all the time, which basically created a running around your tail kind of story for the engineers to keep and try and figure out all the changes all the time, delaying the business by have to wait for the data and unable to work on fresh data because they have to try and run after the changes. So really nice story of a good standard with a good flexibility that covers all the need, but really hard to ingest it. And really this is where Prophecy comes in place. And let's jump into the demo. FHIR is really a JSON, and the JSON in our case is already existing, landing for us on a Databricks volume. In Prophecy, we can open up the JSON file, and we can very quickly look at it and ask Prophecy to basically bring it down and understand what entries we have. One of the crucial parts in FHIR is a resource type. Resource type is a definition of the nested JSON that explains what are the elements that you'll be able to find in there. We can find addresses, we can find the care team, we can find devices, claims, and somewhere down below there's a patient. Spark has a big problem to load it, as the structure is changing and the metadata is not consistent among all the sub-JSONs. But Prophecy can read it and can parse it and build this visual indication and helps you understand which are the resource types existing in this file and how do you like to work them. As we uploaded it, we can add some metadata. You're all familiar with the Unity Catalog metadata, file location, and other. We do a repartition. And right here in the FHIR hierarchy, we can pick and choose and select what elements do we want to load. We can load them all, but some of them might be more interesting. The same examples that we've seen are the naming conventions. Some of them were unique, one name for a patient, some of them were multiple. So in here, we can modify and change it and pass down the road, whether an array or a string for the name, that we'll be able to deal with it later downstream. Another good example is the identifier. Patients have many different IDs. Think about social security number, driving license, Medicare ID, and so many more. In this case, what we want to do is we'll pivot the data by the patient and we'll create a separate column for each and every one of them. This is good for HIPAA. Now we can create a masking on the same ID in Unity Catalog, or we can prevent the end user from seeing it at all. However, some of the users will be able to see it, and then they will be able to define their own masking options right here within Prophecy. Make everything simple. We're just saving everything, all the 320 columns in this example. And yes, this is all synthetic data by Synthra. And just save it into a Databricks Unity Catalog table in a bronze level. Looking at the catalog, we can see that we have the table ready for us right here under FHIR. And here is a bronze table in Unity Catalog. Prophecy works within the Unity Catalog and Databricks domain, which means that all the compute is running within Databricks. All the governance is inherited by Unity Catalog. So there's no runaways, there's no data leaks. and they can simply use, the data engineer or the data scientist later on can use the same data that we loaded. And this is a table within Databricks. And as you can see, a lot of these columns are basically null, because some of these columns are pair resource columns. Prophecy comes to help in here as well, and we can create a silver pipeline that dynamically will go over every resource type and generate it and update its own table. So the first thing we'll do is we'll read the same board table, we'll reformat it, create a filter, and then we'll create a unique list of all the resource types. As we saw before, claim, device, patients, etc. Prophecy has a unique option to what we call a table iterator that can get the list of the same resource type that we just created and do a for each loop that you're familiar with and run this sequence of processes for each and every one of them. We call them gems. We'll read the bronze table, we'll filter it only for this resource type. Keep in mind, this is all running in parallel in Spark. And then we'll basically remove all the null columns for this specific resource type. And everything done here in Prophecy, your analyst or the data engineer doesn't have to code. They can just use these predefined processes. And then we store them all with an underscore silver table, which again, we can see right here in the same schema in Unity Catalog. And if we're looking at a claim, we'll see only the column names and data that is relevant for the claim resource type. Awesome, we have the data loaded, but what about the analyst? What can the analyst do with the data right here in Prophecy? I created a simple job in Prophecy pipeline that the analyst can do very easy. You can see that there are like only 5 steps in here. It joins the encounter information. Encounter is a patient visiting a doctor with the patient information by the patient ID. And we can just bring over by the patient ID and then the file path. In FHIR, patient ID is only unique for the same file. So we have to make sure that we're not cross-joining across files. And we can just pull everything in. We can deduplicate it if needed, but then we can do an order by and create a visit day, because we want to find out recurring visits for the same patient in the same doctor. Yes, we can use a window function. I can drop on a window function gem into it. I can partition by the last name of the patient and the doctor name, order by the date, descending in this case, and I can highlight and get the lead function in there. In Excel, you can achieve the same one by looking at the before or after record. And basically what we're doing is we're pulling the next record, visit date or duration, into our record. Keep in mind, this is descending, so I'll see the latest visit first and all the previous historical visits after. Now I can reformat and I can find out, I can put a rule that if the visits, the difference between the visits is less than 30, and yes, this is a repeating visit indicator, otherwise it's a low. As I hit the run button, Prophecy connects into your Databricks compute, runs the query based on the same data that we stored in the silver tables. And now as an analyst, I can start and see the data popping up on each and every gem, or not. Well, sorry guys, it's a demo, and it usually works. Okay, we're not going to troubleshoot it right now. Oh, overwrite mode, yes. Let me just drop the table and rerun it again. What happens is that the table already exists and the override is there, but the schema was already defined. Sorry, running again, you can see the data grid after the join, and then the analyst can understand the processes that he ran through, what the data that is coming in each and every stage. And at the end, get his report and find out whether there is a repeating visit or not for the same customer, patient, and the same doctor. So what we've seen so far, simple 3 pipelines that cover FHIR ingestion, standardizations into separate silver tables, and an analyst work that can come up and understand repeating visits, quality of care, claim, or any other questions that they have to report and answer for their daily use. Keep in mind, the gold version of the job can be done without a data engineer holding their hands. So really releasing the data engineer to focus on hard problems. Think about machine learning prediction, populating all this data de-identified into a reg and having an AI agent running on top of it, while the analysts can do their job and independently of the data engineer and have to wait for it. So to cover it, we started with a big JSON file, JSON of JSONs that can change and is flexible. But we've seen that with Prophecy, I can modify to my needs. I can pivot and unload and load the data in a way that it's easy for me to manipulate it later. We load it directly into the bronze, and then we created separate tables by resource types for each and every one of these resource types. Again, we did it with only 2 pipelines, not hundreds of notebooks per resource type that has to be maintained. We simplified the ingestion, extended the transformation, and we allowed the end users to do a self-service, create their own reports, schedule it as a job on Databricks, and get the insights that they're looking for. Behind the scene, all the code that we created in Prophecy can be stored in a Git repo. It can be scheduled directly from Prophecy as a job, but the same Git repo can be CI/CD'd and create your own pipelines in Databricks. And everything, again, is running under Databricks governance with Easy Unity Catalog, which is one place for you to see all the audit logs and all the activities across all your enterprise. And build a model directly for FHIR. And that's Medline. Everyone is happy. And with this,
all right,
going
great.
back to Matt.
Thank you, Itai. I think we're gonna just go right through to finishing up here. So thank you, Itai, for taming FHIR. Very difficult standards to get a hold of, and seeing how, with the visual platform, as you can see, we've actually brought more people into the process. So instead of having these very complex industry standards be off to the side, they're now made available to everybody that needs them, but we're still in the managed and well-governed side of the fence, and that's kind of what Prophecy is up to. We're here to deliver the self-service that you need, that everybody needs now in this era. Sorry. Hello. Anybody? There you go. Deliver the self-service you need, that everybody needs, to bring the data experts, the people that know and really working on the problems, into the process, but the governance, enterprise readiness, and of course that setup that the data engineers can do to make these data sets accessible. So industry standard data, which is everywhere now, gives you a head start, but self-service and governance and Prophecy's unique capabilities really put it into play and can make a difference in your business. Thank you guys all for coming. We are here at the show for doing quite a lot. I want to just point out at 3 o'clock, our founders are going to take this conversation further, talk about pipeline generation in the age of AI, talk about AI agents, doing some of the conversation and generation that's out there, that's happening out there at 3 o'clock today. If you're around, you should come to the best event at the evening event at the show. We're up at the View, and we've got even more, but mostly we're right over there at booth 505. Take this conversation here, we've got a few minutes here, and come see us and visit us. So thank you guys again, and thank you Databricks for hosting us, and thank you Itai.
Thanks, Matt.
For a great job. Thanks.